Right, so third and final lesson, critical path analysis, is where we're going to use our network that we've done a forward pass and backward pass on, and we've worked out all the floats, and we're going to basically answer some practical questions relating to the job that we're doing. So, here is a network all filled in. How can we work out how many workers we need to do this in 17 days? So we know we can get it done in 17 days, but how many workers are we going to need? Any ideas?
17.
17 days.
17 days
Is
so
how, well, if we have 17 workers, what, 17
Well,
workers
10.
working for 17 days?
So if there are 10 jobs, because it goes up to J, right?
Yeah.
J, so
Yeah.
say 10 more.
Yeah, 10 workers, yeah. Yeah, I suppose so, yeah. If you had literally had one worker per job, then you would have 10 workers. Obviously, like, for example, the worker assigned to G is going to have to wait until worker assigned to C is finished in order to start, in which case, why doesn't the worker that's doing C do G as well?
Unless
Yeah.
it's specialist.
He's a specialist, he could be, but let's assume they're not specialists, they can all do all of it, right?
Okay.
So we could have 100 workers and just have a load of them drinking tea. We could have 10 workers, one for A, B, C, D, E, F, G, H, I, J, and when they finish their job, they just sit about and drink tea. But what is a lower bound for the number of workers? Like, what might we be able to get away with?
Right, so A could also do D, so that's one worker.
Yeah.
Right? And I suppose the same worker could go on and do E as well.
Yeah.
So that's one worker.
Yeah.
B could go on and do F as well.
Yeah.
And could also do H. So
Yeah.
that's two workers.
Yeah.
And this one who does E can also do J, so
Yeah.
it's still two.
Yeah.
C can go on to do G,
Yeah.
but someone else is doing H, so that's he's kind of made redundant there. So that's three.
Yeah.
And then someone else is going to have to do I, so I suppose 4.
4. Would someone else have to do I? What's the float on I?
The float is 1.
The float
Oh,
is...
float on I.
Yeah.
The float on I is the float on I is 3, right? No, it's 4, sorry.
Yeah, 4, because it could start at 10, it doesn't have to finish until 17, and it's got length 3.
Yeah.
So, the person doing G could do G for 2,
Yeah.
and then do I.
Yeah.
Yeah? Because then they'd start at 10, do G, that takes 2, then the H person can kick off with H, meanwhile, the G person can then do I, which is going to take 3, still going to finish before 17.
Yeah,
Yeah?
it's going to have 2 hours.
Yeah. So we reckon 3 workers.
Yes.
Yes. Now that was quite a complicated way of thinking about it, yeah?
Yeah.
A really easy way to get a lower bound is to think of this as a bin packing exercise where you're trying to just literally fit these jobs into 17 days, forgetting all precedences and everything. So if we just literally get the jobs, we've got A, B, C, D, E, F, G, H, I, and J.
Yeah.
And forget all precedences, pretend we can do them all in a row, like anybody can do any of them, it doesn't matter. But we've got to get them done in 17 days. So, for example, that's 17 days there, and that's 9, and that's 17 there.
Yeah.
And now, this is not very practical because we can't do B after C, or whatever it is. But as a really basic idea, what we can do is add up the total length of the jobs. And I did that earlier. And it comes to... No, I didn't do it.
Okay.
I just wrote it down. Okay, let's get a calculator. Okay, you have them up.
Yeah.
Okay, so it's
17 plus 9 plus 17 again, plus 8, 10, plus 4, 48.
Did you...
So there again,
Yes.
10 plus 7.
10 plus 7.
Plus 4, plus 5, plus 8,
Yeah.
plus 6, plus 2, plus 2, plus 1, plus 3, yeah, 48.
48, brilliant. Right, so we've got 48 days worth of work.
Yeah.
Admittedly, in groups that can't be chopped up, and also with precedences that have to hold. But forget that. 48 days worth of work which has to be split up into 17 days. So what's 48 over 17?
It's 2.8.
Something.
Yeah.
So if we could just chop these up any old how, we would still need 2.8 lots of 17 days. So we would still need 3 workers. So your idea of 3 workers based on thinking about it seems to be about right. And that is a lower bound for a number of workers. We might need 4. We haven't worked it out yet, but we might get away with 3. We're definitely not going to get away with 2.
Yep.
Okay? Right, another question that we might ask. If I turn up on day 11, what might be happening? Can you see that from this network? On day 11, what would be happening?
It looks like, I suppose because these are the lowest, so this is where I get confused between the bottom and the top of the box. So if it was the top, I would say G.
Well, the top of the box is the earliest that the jobs following this event could start.
Right.
And the bottom of the box is the latest they must start by.
Right, I see.
So G and I could have started on day 10.
Yes.
But they could wait until day 11. It's not going to be a problem.
Okay. So yeah, I could expect to see G and I.
Yep, G and I.
I could expect to see. Ooh.
Gets a bit tricky, yeah?
So F would be kind of halfway completed.
Yeah, because we know that F's got to start on day 7. And it's length 6.
Yeah.
So F should be happening.
Yeah. So it'd be halfway through that or something.
Yeah.
E again has a float of 1 day, so it should still see it happening by 11.
Yep. That's it.
That's it. Yeah.
Yeah, exactly. Now that's, again, you can answer the question looking at the network, but it's complicated.
Yeah.
And what a Gantt chart allows you to do is to see things much more clearly. So we're going to put these jobs onto a Gantt chart. Now Gantt chart represents each job, and it shows what's the earliest it can start, how long is it, and what's the latest it can finish, and it shows its float.
Okay.
So what we do is, with any Gantt chart, we start with our critical activities, our critical path at the top. So I'll put the floats on. So one of our critical paths is A, D, F, H.
Yeah.
So if we put that on, A is length 2.
Yeah.
Then D is, what was that? D. Then F is 6. 1, 2, 3, 4, 5, 6. There's F. And then H is 4.
Yeah.
And we've got another critical thing, which is B, so we put that on as well, and that's length 7 there.
Yeah.
So that's all the critical things. They've got no floats, they must happen at those times. Then what we do is alphabetically go down the rest of the activities, and they all get their own line, more or less.
Yeah.
So if you think through the alphabet, and it is very easy to lose activities here, when I mark a whole set, at least a couple of people have missed a letter.
Okay.
So A, B, C, D, E, F, G, A, I've forgotten the alphabet. A, B, C,
H, I, J.
Is that it? Well, yeah. That's it. So so far we've done A, and we've done D, and we've done F and H, and we've done B.
Yeah.
Okay, C. Now if you look at C, where is C? There it is. The earliest it can go is 0, and it's length 10.
Yeah.
So it goes across to here. But it could finish as late as time 11. And we show the float like this.
Right.
Okay? That's C done. E is, here he is. So 7 is when he can start. Then he gets a new line, yeah? They're all on one line now. E is length 8. 1, 2, 3, 4, 5, 6, 7, 8. That's E. But it could go as late as time 16. He's got a float of 1. So there's that one. I've already got F. G is here. He could start time 10. He's got a length of 2, and he could go on as late as 13 if he wanted to. So that's a float of 1. And that's G. I is here. P can, no, that's J, thanks. I is here. 10 again, a 10 start if he wants to. Length of 3, but float of 4. Because he could go on later if he wants to. And then J, the last one, 15 to 17. So 15 to J's got length 1, float of 1.
Yeah.
That's it, that's a Gantt chart. Okay, so you chuck them all on very carefully. Students always go wrong on the Gantt chart, at least one or two, something's in the wrong place or a float's wrong or something like that, or a letter's missing, so being really careful. And then you have the red stick of power to answer all your questions, okay? So when you are so this is like a tidy version of what we just drew, this Gantt chart's the same. So you're the boss, you come along on day 11. This is a day in between these two lines. This is day 1, day 2, day 3. So you could call that one time 2.5 or day 3.
Okay.
So day 11 we were looking at earlier is here.
Yeah.
Now just looking down you can see exactly what's happening.
Yeah.
F has to be happening, it can't move. C, we didn't think of C, did we? I think when we were looking at it before, I don't think we particularly thought about C, did we? Down here? I think, yeah, we did. I think we talked about G and I.
Oh, yeah, we said.
But I'm not sure.
We said C.
Yeah, C
maybe.
could be.
Yeah.
So you can see that C, it depends whether or not it's moved into its float.
Yeah.
So if it's down this end of its float, then it's happening, whereas if it's here, it's not happening.
Yeah.
So E, even if it goes right to the end of its float, it's still happening on that day.
Yeah.
G could move into the right-hand side of its float, and then it's not happening on day 11, but maybe it is. And I could move anywhere into its float and not be happening on day 11. So the things that must be happening are F and E. The things that could be happening are F, C, E, G, I.
Yeah.
So that's mostly what we use this bit for, is to see what's happening at a certain time, what must be happening or what could be happening. The other thing we can use it for is minimum number of workers. Now you can see on this particular Gantt chart that if I move G and I out the way, there's only 2 jobs that have to be happening on that day. Now if there's only 2 jobs that have to be happening, I only need 2 workers.
Yeah.
Now let's have a look at anything else. Now on day 10 there's 3 jobs at the moment. I can't get C out of the way day 10, and actually I can't get E out of the way either. So on day 10 jobs F, C and E must be happening.
Yeah.
So if 3 jobs must be happening, only 3 workers. Now maybe there's a day where 4 have to be happening. So even though we knew there was a lower bound of 3, it doesn't mean that there isn't a day on which 4 workers are needed. So we have to kind of move this across and think, is there a day, there's 2 there, 3 there, 3, that's 2 workers, that's 3 workers needed on that day, that's 2 workers because I could move G left.
Yeah.
Sometimes, worst case scenario, you have to really think, because you start shoving everything to the left of its float to get it out of the way, and you don't realise that in doing so you create a day on which...
Yeah. Exactly.
And then when you get down here you shove them left, and when you're here you shove them right, and you keep saying I don't need the workers, but actually you do, because you can't shove them left and right simultaneously. But with this particular one, there isn't a day on which you need 4. There is a day on which you need 3, day 10.
Yeah.
So as an argument for how many workers you need, you'd say you need 3 workers, because on day 10, jobs F, C and E must be happening. Therefore you need 3 workers.
Yeah.
Yeah. So the Gantt chart's good for what's happening on a certain day, what must be, what could be, and also how many workers do I actually need to do the job.
Nice.
And that's a Gantt chart. So the other thing we can do is schedule, and we've got a different network here, and not a Gantt chart, because we don't need a Gantt chart to schedule. We do need all the information, but we don't need a Gantt chart. So what we're going to do is we're going to give these jobs to workers, and we're going to try and get it done in 29 days, because that's the number of days we can get it done in, and we must stick to the precedences. Now the rule is that you start by giving worker 1 critical path.
Yeah,
Worker
so
1 just does the critical path. So we have worker 1, like that,
Yeah.
and we give them C, and then E, and then J. Then they're busy all day, or all 29 hours, whatever it is. So they do C, that goes to there, and then they do E, which is 7, 2, 4, 6, 7, and then they do J, which is 10, 2, 4, 6, 8, 10. worker 1's full.
Yep.
Okay, worker 2. So you just basically start giving them jobs.
Okay.
You try not to use more workers than you need. We know we need 3. And you just keep a really close eye on precedences, basically. So do you want to assign people some jobs?
So worker A needs 5 hours.
Worker 2 is doing A.
Oh,
yeah.
sorry. Worker 2 is doing A.
Yeah.
So that is job A.
Yeah.
And then afterwards, what, I can give him H.
Yeah. What is sometimes a good idea is to just keep things as early. It's rather than filling up worker 2, take your jobs as you move through the network and give them to worker 2 or worker 3, whoever's available.
So,
including precedences.
so should I go to D then?
Yeah. So
Right,
if you
so
now
you
give worker 3 D.
And this is 9.
Yeah. Okay. And now you can kind of think, right, what about job B?
So
It can't start.
Am I not looking at floats with that?
You're looking at floats in the sense that you might want to shift it right a bit. So there might be a situation now in which we want to give job B to worker 3. Now worker 3 can't start B at time 5 when it could start, but so long as worker 3 is available to start it by time 8, which actually he isn't in this case, but if he was, then you can give it to him.
Right.
So you're keeping an eye on the floats because you do want to finish in 29 days, and you can use them if you want them to.
Okay. I'm gonna tick these off.
Yeah, good plan, good plan. Yeah.
Okay. So now I can move on to H.
Yep.
So if I continue with giving worker A H.
Yeah.
So that's,
Because there's no reason to delay it.
yeah. So that's the 15.
Yeah.
15, right?
Yeah.
H.
Yeah.
So that's ticked off, and then
Yeah.
I can continue down. Now, this job B, I can't give it to C because that's the critical path. D is already on a job.
Do you mean worker 3 and worker 2?
Sorry,
Yeah.
worker 3 and worker 2. So how?
Well, if you look at your schedule, basically someone's got to do B.
Yeah.
Now, B, the earliest it can start is 5. Everybody's busy on day 5, and day 6, and day 7, and day 8, and day 9, as it happens. So it can't start until day 9 because everybody's busy.
Yeah.
But it can start on day 9 if you give it to worker 3.
Okay. So we give that one. So it's 4 days.
Yeah.
What day is this on? This is on day 10, isn't it?
Yeah, that's day 10.
Should be on day 9.
That's a good point.
Right, okay. Day 9. And then we're adding the 4 to day 13.
Yeah, that's it. And the only thing you just have to keep checking that your precedences are holding.
Okay.
So you've got B going. B is dependent on A. Has A finished by the time you...
Yes.
Yeah, so it's all right.
Oh,
so that's
right.
fine.
Okay,
Yeah.
fantastic. And then we've got, we carry on down the network. So J's already been dealt with.
Yeah.
B has been dealt
Yeah,
with.
that's
So
the critical part.
done. Now I can go on to F, I suppose.
Yeah.
So F requires 5 days. So you can give that to worker 3 or
Yeah.
worker 2.
Well, if you give it to worker 3, he could start it on day 13.
Yeah.
Whereas if you give it to worker 2, he would have to wait.
Until
Now that
day
doesn't mean, this is quite fiddly, that doesn't mean this is going to be the best thing, but for now I would give it to worker 3 because worker 3 can start earlier.
Okay. So worker 3 can do this. This
Yeah.
is work 5. So 13 plus 5 gives me
Yeah.
18, and that's F.
Yeah.
So that's done.
Yeah.
Then I've got to look at G and I. So G is worth 13, so that's a big one.
Yeah.
So probably could give that to worker 2. Right. Oh no, but that's dependent on BC.
Exactly.
And so I can't give that to worker.
Now you can see from this that this event here that tells G to start is critical. The event itself. The earliest that whistle can go is 12, and the latest it can go is 12, so G has to start at 12. Actually, no, that's not true. That's a complete lie. The whistle is critical because E is a critical activity. So it has to go at 12 so that E can go, so that J can go, so that we can finish.
Yeah.
But G has got float of 4.
Yeah.
So that's all right. So we can shove G forward a bit, can't we? So G
So-
could start at 12, but it doesn't have to start until 16.
And 16 is not right yet, so it can actually,
Yeah.
I can give it to worker 2.
Yeah.
I can give it to him straight after, right? So if he
Wasn't that
finishes
15?
Yeah.
Oh yeah, you can start at 15, yeah.
So I can give him 13, so that goes up to 28.
Yeah.
So he'll finish there,
Yep.
and that's
G.
And worker 3 is left with the R, so that, and he's allowed to start that. Yeah, he's got leeway, so we can
Yeah.
add that 5. What was he on? Was he on 18?
He was, yeah.
Alright, so that will give me 23. Cool.
Yeah.
So
Okay.
that's done, right?
Brilliant. Now, what the examiner's going to do is to have a list of precedences, essentially. And so when you're doing this, it's a really good idea to just check that your precedences hold. So I look at activity I. It's dependent on F and H. Look at where F finishes. Look at where H finishes on your schedule. Is I starting after them? Yes, it is. And then F. F on here is dependent on B and C, and that's all. So look at F. Does it start after B and C finish? Yes, it does. And it's tedious, but it's really, really worth just going through and going, yep, just comparing to the precedences and checking that you haven't made something start, you haven't accidentally moved it left to fill in a gap when it can't actually start until something else is finished. If a worker has to wait, if a worker's doing C, but it can't start D till here because D depends on F and F doesn't finish till there, then you just put a little gap. It's fine. But don't be tempted to shove your D back if D depends on F and F isn't finishing till another time. Yeah?
Right.
So it's the precedences that are really important. So what we were doing here was we were using the floats and the early and late times and all that because we were finishing in 29 days.
Yeah.
Now, in order to finish in 29 days, we need 3 workers. If we only have 2 workers, we can't finish in 29 days. Okay?
Yeah.
So if we only have 2 workers, just the whole concept of all of this goes out the window. Because we can't finish in 29 days, it's impossible.
Yeah.
So they're just jobs now that need doing as quickly as possible. The precedences still hold, but there's no float, there's no early and late and things because they all help you finish in 29 days and we can't finish in 29 days because that leaves 3 workers and we've only got 2.
Right.
So now you're still scheduling worker 1, worker 2, keeping an eye on your precedences, which I've written a precedence table here, which you can also see from the network, but table network doesn't matter. But the point is now all of those numbers that we've been focusing on are irrelevant. We're just going to give the jobs to worker 1 and worker 2, and we're going to make sure we stick with the precedences, and we're going to try and do it in as least number of days possible.
Okay.
Now, have a go. There was one of these, it wasn't this one. Actually, it might have been this one, I can't remember. That I did it before a lesson, and I came up with 42 days, and I really thought about it, and you definitely couldn't do it in less than 42 days. And then I did it with a class, and they got 43 days, 44 days. And I was like, oh, look how clever I am. I did it in 42 days. And then another class, someone did it in 39.
Wow.
It might have been this one, it might not. But it is kind of difficult because when you do it, you don't know if you found an optimal solution.
Yes.
But again, most important thing, just keep an eye on those precedences because you can't have jobs going until the thing they depend on have finished.
Okay.
So just see how it goes. I don't actually know what the answer is, but see if you can see how small you can get this total.
I mean, logic's telling me to start on the critical path bit, but I know
There is
you
no
said-
critical
yeah,
path.
exactly. But
Yeah,
I mean,
yeah, exactly.
right. So worker 1 will just start off systematically. I suppose.
Yeah. Well,
So-
you say that, but you've got 3 that can kick off, haven't you? And you've got 2 workers. So either job A is going to have to wait, or job C is going to have to wait, or job D is going to have to wait, because you've only got 2 workers.
Right, I see. So job 12 is the longest, so that has to be done.
Yeah.
So it
Yeah.
makes sense to give them that first.
So that's
what's
C.
that,
Yeah.
Right. Now we
Okay.
can kind of,
C is done.
yeah. C's done. Meanwhile, so this one is difficult.
Yeah, it's really difficult.
So,
It's really difficult.
I suppose it makes sense to give him the second long list. I know in reality I would give one of them the long one, and keep giving them long ones, while the other one does the quick jobs and mops them up. But they're dependent on each other.
Yeah.
Okay, I'm gonna get him to do.
There isn't actually, I'm not doing that thing of like, oh, in a minute I'll show you the way to do it. There isn't a way to do it.
Okay, so I'm gonna give him the little ones. I'm gonna go for A.
Okay.
So 5. So that's A done.
Yeah.
And then I want him to do B.
A's done.
So that's 4 done. So that's 9.
Okay.
That's B.
Okay, and I can see from my precedence table here that B depends on A. So have we definitely got B following A?
Yep.
Yep, good, fine.
Cool. So C's done. So now I'd probably switch him over to D.
Okay.
So I'm going to switch him over to D. But that had to start on the. Did that?
No,
start,
nothing has to start any
gone
time.
now.
Nothing has to start any time now. D doesn't depend on anything. So he can just go wherever.
So that's
Yep.
now 18 days. That goes
Yep.
up to day 18, and then worker 1 can continue, and we'll give him job F.
Okay.
So I'll give him job F, and that takes 5 days.
Okay.
Can't remember if that was on 13 or that's on 12.
That was on 12.
12, so give that takes him up to 17.
Yeah. And that's
Okay.
F, yeah? And from my precedence, I can see that F depends on C and B. So is F only going once C and B are finished?
Yep.
Good. Is F done?
And therefore, right. And what's working 2 doing is on D still. So I'm going to give him F. I'm going to give him, oh no, H takes even longer. Fine. Can I give him E?
Yeah.
I'll give him
You
E.
can give anybody anything.
So 7, so that'll take us up to 7, 24.
Yeah.
Right. So that's E.
Yeah. And E depends on C and B. C and B are both finished before he kicks off, so that's alright.
Yeah. So now that's done, I
Yeah.
give worker 2, F's done, I'm going to give worker 2 H.
Okay.
So,
Which depends on A, but A finished ages ago, so that's alright.
that's 10, so that's 18, so that's 28. Right.
H, yeah?
Yeah. That's cool. So that's done. And then at the same time, they can do, I'll give thingy, worker 1G. So that's going to go all the way up to 37.
Okay.
So where's that from? Let's skip one.
Oh yeah.
So
It should be 36, shouldn't it?
36.
Yeah.
That's 38. Huh?
Yeah. Yeah, I obviously just
Was it G?
count. That was G. Yeah, G was dependent on C and B, but C finished ages ago, B finished ages ago, so this is G.
Yes,
And
got to 37.
okay.
37, yeah. Cool.
Okay. Got I and J. Yeah.
So I and J, so
J's.
I'll give that one to give J, so that's 10, so that got to 38. And that's done.
J. J is dependent on E and D, but E and D are both finished. That's all right.
So then finally work up.
So then presumably worker one has
One
to do
can finish.
I.
And that takes another 5 days, so that's 42 days.
I think it was this one. I think it was this one because I remember getting 42. So I depends on H and F, but H and F both finished ages ago, so that's fine. Right, so your precedences are perfect. You have scheduled it onto 2 workers. All your precedences are fine. The only issue is that I think it can be done better.
Right.
So it's an exercise for the video watcher that they're going to try to do it better.
Okay.
So rewind the video and see if you can do it yourself better, basically, because I'm pretty sure that someone did 39 once.
Brilliant.